Well, thanks everyone. Thanks for the introduction. Today I'm going to present what we did in our last paper published a few months ago. Something that I started at the Center of Anthropobiology and Genomics in Toulouse, and that I finished as a permanent researcher at the Institute of Evolutionary Biology. So why is it that we have been so obsessed with horses is because they provided something unique. For the first time that we domesticated this animal, we were able to travel, for example, from Barcelona to Paris in only a few days, which was absolutely unprecedented. So we started to connect with people what we didn't know much about. We started to exchange genes, to exchange microbes, including pathogens. We started to exchange, let's say, goods, religion, beliefs, and even languages. And it's precisely in these fields, in linguistics, where horses have been attributed a very important role. It's well established that more or less almost all the languages that we speak from Iceland to India, they have a common origin. They are Indo-European languages. What is less clear what was the root of this trio family of languages. So one of the main hypotheses is the steppe hypothesis that states that the first speakers, the early speakers of these Proto-Indo-European languages lived in the Pontic-Caspian steppe, and they spread these languages across Eurasia because they had the horse and they had this enhanced mobility from 5,000 years ago. This step hypothesis finds some support in ancient human DNA analysis, which have tested several times very important migrations from the Pontic-Caspian steppe to central Germany. This is known as the Yamnaya phenomenon, happening or starting 5,000 years ago. And once they move into Europe, they develop into a new culture that will be summarized across this along this talk as CWC culture, called the ware culture. So in 2021, we discovered that the ancestors of modern domestic horses lived in the Pontic-Caspian steppe. Indeed, the typical ancestry profile represented by these pie charts was only present, if we look at horses older than 5,000 years old, was only present in the Pontic-Caspian steppe. So horses were there, and then at some point they spread across Eurasia. But actually, even though the similarity in the ancestry profiles was maximized in the central Pontic-Caspian steppe, we could already see that there was some dilution, some leaking of ancestry to the margins of the Pontic-Caspian steppe, up to the Transylvanian Basin in the west, or the Jura Hills at the east. So this is the typical natural clan that you would expect in a natural population. But there was a big but, right, for the steppe hypothesis. Even though the horses were there, we also had some horses that were radiocarbon dated to 4.7 thousand years ago. It were 6 horses that were excavated from an archaeological site known as Hollerstein. These were culturally affiliated to the Cordeware complex, the descendants of the Yamnaya. And when we analyzed the ancestry profiles, when we estimated the ancestry profiles, we saw that they were simply like local horses from Europe, which was against the steppe hypothesis, because if these people associated to the Yamnaya culture moved together with these horses, we should expect a very similar ancestry profile in the origin of the migration and in the destination of the migration, and we detected 0% gene flow almost, right, from the steppe into Central Europe. Actually, we detected in 2021 that horses spread out of the Pontic-Caspian steppe from 4.2 thousand years ago. So this was 8 centuries later than the steppe hypothesis was postulating. So some people was not super happy about this. In 2023, it was this very important paper by the father of the steppe hypothesis, we could say, by the group of David Anthony and collaborators. They did a fantastic sampling job. They excavated more than 200 complete human skeletons, trying to find bone lesions, pathologies that are associated with regular horseback riding. Let's say if you're a regular horseback rider, then by the pressure you have to do with your legs against the body of the animal, you create some kind of deformation in the femur and in other bones, and this can be a marker for horseback riders. So they investigated these more than 200 complete human skeletons associated with, or potentially associated with, Yamnaya context in the Carpathian and the Transylvanian basins, and they discovered 7 out of the 200 and something, so it's a very small proportion already. Out of the 7, 2 were post-Yamnaya. There was no controversy there. 3 were Yamnaya and 2 were pre-Yamnaya. One is slightly pre-Yamnaya, and I hope you can see the pointer of my mouse. It's the first in the list. And there was one that it was very pre-Yamnaya, like it was 6.4 thousand years old, which is older than any other evidence for horse domestication. So 1 out of 7 potentially false positives is a false positive rate of 14%. If you have to multiply this 14% times the 200 and something skeletons they analyze, you will see that you will expect many positives anyway. But we take it very seriously. We assemble a huge, let's say the largest, I think, for animals, ancient genome panel, enriched for these regions from Central Europe and including the Carpathian steppe, which is the Carpathian Basin, sorry, which is here, and the Transylvanian Basin, which is this one, okay, east of the Carpathian mountain range. And you can see that the Transylvanian Basin is naturally connected. There are no mountains to the Pontic-Caspian steppe. So when we analyze all the horses from that region that we had in our panel, and they were older than 4.2 thousand years ago, we discovered a cline of ancestry that it's very likely a wild cline of ancestry, a gradient that goes from this dark brown color ancestry in Central Europe to this mixture of dark brown and orange coral ancestry that is typical from the steppe. Remember, this Transylvanian Basin is naturally connected to the steppe, right? We suspect that we are almost sure that this is a natural cline of ancestry for several reasons we can discuss later. But one of them, for example, is that we have 2 horses from Neolithic Poland that are more than 7,000 years old, and they already carried this orange color ancestry typical of the steppe and typical of modern domestic horses. And this is earlier than any known migration from the steppe, especially from the Yamnaya migration. So there was a natural cline of ancestry from the east to the west, as expected for natural populations. You will see the change when we analyze horses that are less than 4.2 thousand years old. There is a almost complete replacement and ancestry turnover, and all the horses that we analyze that are younger than this age, they have very similar, like really similar ancestry profile, except in 2 that are almost at the limit of the temporal boundary we set to split these 2 things. So it may be that the replacement took a century or something, and these were some of the last survivors. So it's very clear that horse-based mobility in the region arrived very late to the region, and it was not 6.4 thousand years ago as it was previously suggested. Actually, this paper from the group of David Anthony has been recently, and when I say recently, it's last week, criticized by the group of Will Taylor, an archaeologist specialized in horses from the Colorado University. They basically say that if you ride a horse regularly, of course, you can develop some bone pathologies, but you have some bone pathologies doesn't necessarily mean that you were a horseback rider. And this was also pointed out by another archaeologist from Ukraine, who suggested that there were many other possibilities and activities, including cattle riding in the region. Like, for example, the Chumak is people from Ukraine, and they went every year, and they still did in the beginning of the 20th century, to find salt to the Black Sea, and they were covering like 1,000 kilometers every year in cattle. And these kind of activities could resemble or produce the same kind of morphological lesions as horseback riding. There was another line of evidence against our results. They say, okay, they developed these fancy admixtures too, and they try to, well, one of the main functions of this new package is this fine graph function that allows to try to estimate the admixture graph that best fits to the F statistics calculated from your data. So the group from Harvard tried to illustrate the applicability of this function by analyzing some publicly available datasets, including ours. And surprisingly, they estimated that 20% of CWC horses could have originated from steppe horses. So this backed up the narrative of horses, people, and languages going hand by hand, like in accordance with the steppe hypothesis. We were very surprised about this because all the analysis we had done before and all the analysis we were doing were not supporting this. Here is a MDS plot based on F4 permutations done with Extractor4. It's several millions of F4 permutations summarizing this MDS plot. Here in orange, you have the cloud of the DOM2 lineage, the lineage of modern domestic horses. In red, you have the cline we have been discussing about from the Transylvanian and Carpathian basin that leads to Central Europe, which is marked in this darker brown color. You will see in this zoom-in panel that CWC horses that are highlighted in yellow, they are clustering with horses from Europe that are as old as late Pleistocene horses from northern France or Romanian horses from the 36,000 years ago. So it's very unlikely that CWC horses carried 20% of steppe ancestry, and these dots were not moved toward the cloud of steppe points. And this was also very supported by their own programs. For example, QPADM, we were using it, and we modeled the ancestry of CWC horses as a mixture of local European horses, all of them pre-Yamnaya, and no model supported 20 or even 2% of ancestry from the steppe horses into the CWC horses. And many other analyses that I don't have time to summarize. So we were wondering what's happening with AdMix tool 2. And I think this is an important message for the community. Be careful with this function. This is not a black box that will reveal the population structure of your data at once. Be critical with the results. We were able, among the many problems that we found is that we tracked the discrepancy in our results because they were using pseudo-haploid population groups in the analysis they did in the paper and in life, which, as they note in their own paper, still they use it. If you use these pseudo-haploid population groups, you can bias the F3 calculations. So taking advantage of our extended data set, we managed to include at least 2 individuals per group, and we recovered another new population graph that was significantly better using the tools to measure significance, significantly better than that proposed by Meyer and colleagues, and that supported all our original conclusions, including no-gene flow from the steppe into cold horses. We also provided new lines of evidence and new insights into the process of horse domestication. One of them is inbreeding, and we had a very nice introduction recently in the previous talk. So if we look at horses that are older than 4.2 thousand years ago, we see that there were some high levels of inbreeding, but these were in the form of very short runs of homozygosity. In contrast, if we look at horses that are younger than 4.2 thousand years ago, we see that we have high levels of inbreeding, but these are in the form of very long runs of homozygosity. And close-kin mating is producing this. And you can see that close-kin mating is something that horses will never do. These are social animals that will never mate with close relatives because they have this natural mechanism of inbreeding avoidance. And early, from after 4.2 thousand years ago, we start identifying long runs of homozygosity at the level that we could find in modern breeds. And horses are very, very inbred, including in Syntacta context, which are the people that the culture that developed the spoke-wheel chariots. Another line of evidence is provided by demography. So we had a group of early DOM2 horses, contemporaneous, that were dated to, on average, 3.9 thousand years ago. So what we did is to apply a program called GONE to reconstruct the demographic trajectory in the 200 preceding generations. So we saw that the population size in the steppe was relatively large, about 10,000. The horses like the steppes, so that's why the population size in that region is expected to be naturally large. Then, at some point, about 4.7 thousand years ago, we see that the population size drops very dramatically, I would say. It's very rapid, the decline. And this is very shocking because if the Yamnaya had moved together with the horses, it would mean this graph that the Yamnaya were moving when less reproductive horses, less breeding horses were actually available. So this resembles very much what is, I would call, a domestication bottleneck, okay? It took about 75 generations, depending where you put the beginning. And we can see also, assuming a generation time of 8 years per generation, which is very realistic for horses, we can see that the recovery is about 4.2 thousand years ago. This is very important because it means that all this population expansion that we see also in the Transylvanian and the Carpathian basins, it was not only an expansion in space, but also in numbers. They were multiplying horses. And at this point, we wonder, how is it that you go from such a low number of horses to such a high number of horses in such a limited time? And for increasing production, there are two options. So you increase your farm as you expand, which they probably did. Or the other option is that you keep the size of your farm and you produce faster in your farm. And producing faster in biology means to produce more animals in more time or reduce the generation intervals. So we developed a method to estimate generation intervals from genomic time series. We validated the method using coalescence simulations, and we proved it as independent of demography and independent of inbreeding. And basically what it does is that it measures the numbers of generations evolved by each sample to the more recent common ancestor of all the samples that you are considering. For example, this very ancient horse is radiocarbon dated to almost 45,000 years ago, and it has evolved less generation than a model horse that is recent because more time has passed and the model horse has evolved more generations. So the key question here is if this progression is linear, which would mean that people or horses were reproducing at an even pace all the time, all these 45,000 years of evolution, or if there are changes in the slope of the regression, because this could be due to, I don't know, climate change or human agency modifying the generation times of horses for increasing productivity, for example. So we detected two peaks. We fit a generalized additive model to this regression, and we detected three peaks, sorry, one in model times. This represents model breeding techniques, which have accelerated, actually, and you can see, measure that from pedigrees, have accelerated the generation time dramatically in horses. But we detected one at 4.2 thousand years ago at the beginning of the domestication or the spreading, better said, the spreading of Dom2 horses. And we detect another one 5.5 thousand years ago. And this was also very interesting because if you know a bit about horses or the evolutionary history, you will know that there was an earlier domestication attempt. And the earliest archaeological evidence for horse domestication is provided by this ancient human settlement of Botai, which is in would be today in Kazakhstan. And this was a completely different population, a completely different lineage. The Botai horses are not the ancestors of modern domesticates, they are the ancestors of Shavatsky horses. And there are many different lines of archaeological evidence supporting domestication at Botai. For example, there was a huge faunal deposit and 99.9% of the bones belong to horses, despite at this time there were other domestic animals available, meaning that these people had an economy based on horses. They also found isotopes that resemble very much what is expected to be found in equine milk fat, and they have been dating this pottery, and it's 5.5 thousand years ago, so it's at that moment. And there has been also some controversial evidence related to bidware, to damage in the teeth of the horses associated with the bridles and the managing of horses. So there are many lines of evidence, but only because of this was, in my opinion, questioned artificially. This was used to revive the debate whether domestic horses, Botai horses were domestic or not. So we provide a different line of evidence here, because if we remove Botai horses from this regression analysis, we see that this early peak of acceleration of the generation times is gone directly. So meaning that it is the Botai horses that are producing this acceleration of the generation times. And this is important because the only two husbandry markers that we detected in common in the two known processes of horse domestication are not inbreeding, are not relatedness, but are accelerations in the generation time. And we don't detect any other, neither the climate change has produced changes in generation intervals as big as domestication itself. So there was an early domestication attempt at Botai, mainly for meat and milk. And there was a second domestication event process starting in the Pontic-Caspian steppes. And this was the origin of horse-raised mobility 4.2 thousand years ago and not before. Thank you.
Thank you so much, Pablo, for the presentation. That's a massive amount of work. So congrats. Are there any questions for Pablo? I can see Kevin raise his hand.
Yeah, thanks, Laura, and thanks, Pablo, for the talk. Can I ask about the peaks of the delta time?
Yeah.
So it looked like the peaks are kind of quite similar across the three different peaks, even the modern even the modern peak. Is that surprising to you? Like that kind of suggests it's like these earlier domestication processes, the effect on generation time would have been as intense as modern horse breeding practices. That is a little bit surprising to me.
I think there is a problem of resolution in the regression because it implies some smoothing, but it's probably also true that because this translates to 3-4 years per generation, which is almost halving, which I would say is the biological limit of that you can bring down the generation time. So it may be that they are the same because you cannot push it more.
Yeah, that's a good answer. And maybe if I have a chance, can I ask about the Y chromosomes in this scenario? Like, do you see any really strong bottleneck for the sex chromosomes at the DOM2 expansion?
Yeah, absolutely. Horses are known because they have one of the lowest Y chromosomal diversity, like modern domestic horses, among all the domesticates. Like so, only until a few years there was only one haplogroup defined, and it's the opposite for the MT. Like for the mitochondrial chromosome, they have a huge diversity, and for the Y chromosome, they have a very limited diversity. Like this is one of the most contrasting patterns among all the domestic animals.
And so that matrilineal diversity, you still see it in these expanding populations, in these like prior to their expansion.
Yeah, it was there before, so it was there in the Pontic-Caspian steppe already. This large diversity, so it expanded with the lineage itself.
Yeah, cool. Yeah, thanks for the answers.
Let's see, Andres has a question. You can unmute yourself. No, you can. Maybe you can write it on the chat.
Okay, there we go. Okay, so yeah, thanks for the great talk. I think this generation time analysis is really quite amazing, and I'm just kind of wondering because I think probably many of us are wondering, okay, can I apply this to my own species? Obviously, there's similar questions in pretty much every domesticated species, but also potentially wild species as well. But so I'm wondering if you could say something about what kind of data do you need to apply this generation time analysis? Like, do you need a good recombination map? Do you need good kind of modern genomes to define variants? Or like what are the kind of requirements in order to get good results out of this?
So I don't think you need high coverage because at the end the method pseudo-haploidizes internally. You need a good recombination map, that's for sure. And you need, I would say, a quite extensive time series, a lot of genomes that need to be radiocarbon dated. That's the most important thing. The rest, I think, it's just CPU time.
Okay, so potentially we could think about applying this to other species, other domestic species, where we're starting to get quite good time series from some species in the near future.
I mean, for dogs, for example, I think it would be quite important for timing potentially the domestication of dogs, which is quite controversial.
Yeah.
They have a different reproductive pattern. They became from seasonal to regular reproducers, which is, it has to be seen in this kind of analysis. So I don't know when this started, this change in the reproduction system for dogs, if it was at the beginning of domestication, it came later, I'm not sure. But that could be super interesting to know how it changed all this stuff with dogs or with other animals, of course.
Yeah, definitely.
Also with humans, I mean.
Sure. Thanks a lot.
Welcome.
Perfect. I think we have time for questions. I can see we have two raised hands. Thierry was first. So we want to get ahead and answer your question.
Thank you. I have a question about the idea that the bow-tie horse could be the ancestors of the Przewalski. I was wondering whether you can ascertain that they are really the ancestors, or whether they simply belong to similar population, but actually there are two branches that are not related. That it's not a bow-tie horse that became feral that gave rise to the Przewalski. It was just like the same population that gave rise to the bow-tie horse also gave rise to the Przewalski.
So when we do, for example, phylogenies, we see that the genomic variation of Przewalski horses emerges within the diversity of bow-tie horses. It's not a sister clade within the same lineage. They are not two independent clades, but the Przewalski clade is within the bow-tie clade. And when we do an ancestry test, what we can conclude is that the Przewalski and the bow-tie horses belong to the same population evolving through time. This is what we can conclude. We cannot conclude anything else.
Okay. So they belong to the same population. That's clear. But maybe that because the question was that maybe that the amount of domesticated horse in the bow-tie area was not sufficient to have a significant impact on the wild population, even if some of them became feral after.
What we can see and we can test statistically is that the bow-tie and the bow-tie horses were like part of the ancestors of the population. If there was a subgroup that was not differentiated at all but was wild, and the bow-tie belonged to the same population as this wild. So if there was no differentiation, there is no power to differentiate that.
Thank you.
I think we have a last question from Catherine.
Hi, Pablo. Of course, I really love the work and I appreciate all the genius involved in this, and super excited to see it again. And I had a quite quick question about the coat color genetics. I know there was a lot to do in the earlier work, emphasizing coat color as a marker of horse domestication. And I realized, and a student asked me this yesterday, and I didn't have a good answer. And I know it looks like there's been a de-emphasis in the recent work that maybe the coat colors, depigmentation was not a necessary or a big part of these domestication processes. So I just wondered if you could comment on that. Thanks.
Yeah, I do, but I'm afraid because this is being recorded. No, but when we look at alleles associated with coat color variation, we don't see an explosion, as they say at the beginning of domestication. We don't see anything of this. They came much later, or they were segregating already in all populations at very low frequency. So we don't see anything of this.